All right, so first thing, well, I suppose I should just kind of tell you what you're looking at here. So yeah, this is the iPad simulator, obviously, and this is the toolbar that has a number of functions that we'll either be using or may already be evident from their icons. A few things that you might want to know from the outset. This is the debugger down here, which you can pull up to cover the screen if you want to get a better look at your debugging area. And then this little refresh or recycle button flips over to the display, which right now is blank because we haven't done anything, but the idea is that this is your canvas that you paint on or that you add things to. So we'll be flipping that around to see the results of what we're working on once we get to UI-related stuff. So let's begin with just kind of going through some of the basic objects that we'll be using. And let me know if I'm going too fast. Let me know if you want me to stop and explain something. I think that these here, these are just your typical black boxes. These are all mathematical operators. So for example, you have this, which is add operation. This is a exponent. This is multiplication. This is the modulus operator. And so, as you can see, it has multiple white rectangles, which are the ports. Now, in this framework, inlets or ports that accept input are on the top part of the box, and outlets that send data out are on the bottom. So these are inlets, and this is an outlet. And these two inlets are not exactly the same, as you'll see in a moment. So I'm going to take a couple of these number boxes, which are also boxes in their own right, but serve a different function. And I'm going to connect them to the ports of the addition box, just like that. And then I'm going to take one and I'm going to connect it to the outlet. So we've now got an addition box, and we've got three number boxes to show us the inputs and outputs. So let's start adding some numbers. So as you can see, I enter a number into this box. It passes through the addition box and gives us a 10 on the other side. So it's 10 added to 0. So let's put a number in the other inlet. And the number doesn't change. Now, there is a reason for that, which is that not all inlets are the same. There are hot and cold inlets. A hot inlet, like this one on the left, is an inlet which causes the box to immediately perform its calculation when an input value is received. So that's why whatever number I enter into that box, I get a sum coming out of the outlet. Whereas in the left or cold inlet, I have to update the hot inlet in order to get the sum. So this ends up being very useful later on, but just for now, the 30,000 foot point of view is there are cold and hot inlets. We've got a few convenience sort of objects like a numeric slider, which is normalized to 0 through 1, and it's just a convenient way to generate numbers, which comes in handy. So we have black boxes, we have number boxes, we have sliders. this is a very important object here. These are called bang boxes. So a bang, which is terminology just lifted directly from peer data, a bang is an event. A data flow program requires events in order to do anything, in order to cause processing to happen. And so bangs are basically a message that says, now, do it. Whatever it is, just do it. And not all objects respond to that, but many of them do. There's also a load bang, which is a box that sends out a bang once when the program is first loaded. One other object that's pretty important, then I'm probably going to skip over some of these other ones so we can get to the good stuff. And that's a message box. So the message box you can sort of treat as a text field, which means that you can type your text into it and Jello world. And it takes your text and it holds it. And it actually persists it from one launch to the next. So this is the equivalent of, say, defining a hard-coded variable, you could say. But it does end up coming in handy. So message boxes, are good for setting particular values in a program. They can hold various data types, including strings, numbers, arrays, and they don't immediately change in response to input. So, for example, if I send, this might cause it to crash. I don't know. Oh. Okay, never mind. So theoretically, you need to first prepend or put in front of the data a set message, which causes the message box to know, oh, hey, I need to change my value. Now, in this case, obviously there's something wrong, but it is what it is. So, yeah, we have boxes, we have bangs, we have messages. It's sort of the, it's kind of the basic lingo. So, good with that. Let's take a little step up the ladder here. And let's look at some flow control. So, when your entire program consists of a configuration of boxes that handle data, it becomes very important to know how that data is being routed. So, as a consequence, it's very important to have granular control over things like sequencing of when messages are sent. And so for that, we have several objects, and one of the most important is the trigger object, which is what that T stands for there. So a trigger object is an object that has a single inlet and multiple outlets that delivers a specified event to a downstream port in a particular sequence. And the convention here is that messages are delivered from first on the right-hand side to last on the left-hand side. Now, what we should be able to do here is when I hit this bang box, the bang should travel to this message box, then this, then this, then this, and they're all going to this print box, which is going to print them to the debugger. So, assuming I haven't overlooked anything important, let's see if that holds. And so we can see that it does. So this ends up being very important when you get into very delicate operations. This is another use of the trigger box. This time, instead of B's, we have V's, which stands for value. So in other words, rather than sending a bang when the trigger box receives its input, it just sends that value through, and it sends it in a specific order. So we hit the bang box, and we get hello world in the correct sequence. Here's another, this one's kind of a monstrosity visually, but it doesn't bite. So here we have another flow control object, the route object. I'll see if I can get onto the margin here. Well, that's all right. So the route object, similar to the trigger in that it has a single inlet and multiple outlets, but its arguments, the numbers that follow the route word there, have a different significance here, which is that they're used to sort data as it comes in. And so what a route object does, depending upon the data type that it receives, is it looks at the first element of an array or at the first key of a dictionary, and it says, am I supposed to be looking for this? And if it is, it trims that element and sends the rest through. So here we have some message boxes, which are prepended with digits, 0, everything, 1, in, 2, its. And the idea here is that although everything is going to a single inlet, we should be able to get them to go to their correct places because they're prepended with numbers, which the router recognizes. And so we get everything in its place. And I have a few more of these, but I think you'll just kind of pick them up as we go along. The counter makes waffles. Just kidding. It counts. So one more kind of introductory piece here I want to show you, and this is one of my favorite features, which is the power of abstraction that I was referring to earlier. So here we have a random black box, and my comment is off screen, but it says, anybody in there? So, well, let's find out. Pull that up a little bit so we can see what the response is. And let's send it a bang. It says, ouch. Let's try again. Hey, knock that off. Ouch. Hey, stop. Well, obviously, whoever's on the other side of that inlet doesn't want to have anything to do with us. So let's try the right inlet. Well, that's not very helpful. So let's look inside the box. And so now we've opened the box and we can see how it's implemented, and we can change it. And those changes will take effect immediately. So here you can see I just have a little counter set up that is bounded, lower bound at 0, and then it passes through a modulo 3 box, which means that we just get a repeating sequence of 1, 2, 0, 1, 2, 0, 1, 2. We have this select box, which sends out a bang when it gets a particular number, and that's how we get that repeating sequence of ouch, hey, knock that off. Whereas on this side, we just have a single message. So anytime you send an event into that inlet, you're going to get nobody here but us chickens, which isn't very helpful, so let's change it to don't bother him, he's having a bad day. So, and we could change anything we want about this box, but right now I just want to demonstrate that you can make changes to the internals of an object and you don't have to recompile. It's already running. So that's what I mean when I say real-time editing. Now that's not always going to be true, but often it is. Yeah, so that give you kind of a bit of a idea of how this works.